All right, so I've started to work this one out already somewhat. We've got the length, width, and height of a suitcase to be allowed as a carry-on object onto an airplane cannot exceed 64 inches. So we're told that the height is fixed, and we're trying to maximize the volume. So I'm going to go ahead and say that I want a big piece of luggage. So I'm going to say length plus width plus height is 64. Okay. I'm going to subtract W and H from both sides and find out what L is. So L is going to be 64 minus H minus W. And then I'm going to find the volume. So the volume is L times W times H, which I know what L is. So I put the W and the H right here, and then I substitute it in for L. So I'm going to go ahead and distribute this. So this is going to become 64 WH minus H squared W minus W squared H. Okay, so that's what I have at first, and what I would like to do now is take a derivative. Now we're told that the height is fixed, so we're going to be doing what's called holding H constant. We're just going to pretend that H is a number. So when I take this derivative of dV dW, because remember H is constant, then this derivative, the derivative of W is 1, so I've got 64H minus the derivative of W is 1, so I'm left with H squared minus 2WH. Okay, so notice that everything, actually let's put that in, it doesn't matter, but we'll put it in alphabetical order just to be organized throughout this whole thing. So I have HW squared, and then that's 2 HW. Okay. So from here, I have now taken a derivative. I want to set this thing equal to 0. So right now I've got just W's in this case. So I am going to take this derivative and set it equal to 0. So I've got a 64H minus H squared minus 2HW equals 0. And what do all three terms have? All three terms have an H. So that leaves me with 64 minus H minus 2W equals 0. Well, H cannot be 0 because otherwise we would have no suitcase. Okay, so that means that I'm going to take this and I'm going to solve it for W. So I've got 64 minus H minus 2W is 0. So I'm going to subtract 64 and add H. So negative 2W is a negative 64 plus H divided by negative 2 is going to give me a W equal to 64 minus H over 2. So that's what I've got so far. I did flip my paper. Okay, so we know what W is. So I'm going to go back into the length equals 64 minus H minus W. And I'm going to substitute in for W. So now my length equals 64 minus H minus W. Okay, so this gives me 64 minus H minus 32 plus H over 2. Okay, so that gives me 32 negative H plus half of an H is a negative H over 2. So if I get a common denominator here, I will end up with 64 minus H over 2. So now I know what L is. It happens to be the same thing that W is. So if I look at my volume as being length times width times height, my volume is now length of 64 minus H over 2 times width of 64 minus H over 2 times height, which is being held constant. So I can rewrite that as 64 minus H over 2 squared times H, and that's the maximum volume as a function of H. This is the maximum volume as a function of H. So I'm going to go ahead and expand this. I now have the volume as a function of H is 64 minus H squared over h. This becomes a 1/4 because 2 times 2 is a 4th. And I'm going to expand this out. So I've got 1/4 of 64 times 64 is 4096. I'm looking at my notes. Minus 128h plus h squared all times h. Okay. So now I'm going to distribute the h into there. So I get 1/4 4096h minus 128h squared plus h to the third. And now I'm trying to maximize volume. So I've gotten all of this down to where my only variable is h. So now I can take a derivative. 1/4 is coming along for the ride, so I get 4096 minus 256. Do you hear my dog barking? Plus 3h squared. Okay. And I would like to set that equal to 0. So I've got, I'm going to rewrite it as this way, 3h squared, where I forgot my h. Oops. No, I didn't. Everything's fine. Minus 256h plus 4096 all over 4 equals 0. So I'm going to multiply both sides by 4. I get 3h squared minus 256h plus 4096 equals 0. And then when you use the quadratic formula, so let's use quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get 256 plus or minus 256 squared minus 4 times 3 times 4096 all over 2 times 3 is 6, and I need to go find a calculator. Hang on. Okay, so putting this in the quadratic formula, we get two answers. One of them is h equals, and I should have put h equals here instead of flipping around my variables. One of them is h equals 64, and the other one is h equals 64 thirds. Well, the height has to be constant. The height can't be 64 because the maximum of the length, width, and height added together needs to be 64. So this is just one-dimensional. So it can't be 64, so our answer must be 64 thirds. All right, so for the next problem, we've got a curtain rod that we're trying to get around a corner. This is supposed to be a straight line, and I wasn't paying attention, and it's not very straight. So just understand that that is supposed to be a very, very, very straight line. Let me just see if I can fix it. Okay, so we're coming down this way, and there we go. So this part of the hallway is 5 feet wide. This part of the hallway is 8 feet wide. And I've got an angle measure of theta on both sides of it. And that theta is going to be equal, okay, because of vertical angles. So what I have is the length that I'm looking for, I just erased my x, is x plus y. So it's this hypotenuse plus this hypotenuse. So L is for length, the length is x plus y. Well, I know that the sine of theta is 8 over y. So that would be opposite over hypotenuse. And I know that the cosine of theta is going to be 5 over x, which is adjacent over hypotenuse. So I know the two pieces of information that I need. So I'm just going to add those two things together. So I'm actually going, hang on, before I do that, before I skip too many steps, I'm going to multiply both sides by y. And then I'm going to divide both sides by sine. That's an 8. 8 sine theta. 8 over sine theta. Which gives me y equals 8 cosecant theta. And I'm going to do the same process over here. I'm going to multiply both sides by x. So I get x cosine theta equals 5. I'm going to divide both sides by cosine, so I get x equals 5 over cosine theta. And then I have x equals 5 secant theta. Okay, so that is what I know so far. So I can take this, and now I can take a derivative as soon as I add these two things together. So my length is going to be x plus y. So my length is going to be 5 secant theta plus 8 cosecant theta. And now it's ready for me to take a derivative. So the derivative of secant is secant tangent. So I have 5 secant theta tangent theta. The derivative of cosecant is negative cosecant cotangent. And remember, we want to set that equal to 0. So I'm running out of room, so I'm going to consolidate a step. I'm going to add this over to the other side. So I'm going to add 8 cosecant cotangent theta to the right-hand side. And that's going to give me L prime equals, what did I just say, 5 secant tangent. So I've got 5 secant tangent equals, I had it set equal to 0, and I don't want to have a whole bunch of equal signs all floating all over the place. My dog is behind me now after she just barked a while ago. All right, and that's going to equal a positive 8 cosecant cotangent. Hold on. Okay, so setting this equal to 0, I add that over, and now I'm going to rewrite these things in terms of sine and cosine. So 5 secant is the same thing as 1 over cosine. Tangent is the same thing as sine theta over cosine theta. Cosecant is the same thing as 1 over sine theta. And cotangent is the same thing as cosine theta over sine theta. So I have these ratios that just came straight down from here. Okay, it's kind of fuzzy. I'm easily distracted. All right, so now I'm going to put this thing together. So I've got 5 sine theta over cosine squared theta equals 8 cosine theta over sine squared theta. And at this point, I'm going to cross multiply. So I cross multiply this way, I get 5 sine cubed equals 8 cosine cubed theta. So if I divide both sides by cosine cubed, and then divide both sides by 5, I end up with this right here turns into tangent cubed equals 8 over 5. So now I am almost done with this thing. I need to take a cubed root of both sides. So tangent theta is going to equal a cubed root of 8/5. And now I need to know what theta is. So when I find theta, I'm going to do the arctangent of both sides. So theta equals the arctangent, or the inverse tangent, of the cubed root of 8/5. So when I find out what that is approximately 0.8634. So we know that L equals x plus y, which in our case, L was, what was my x value? I've lost it. My x value was 5 over cosine. Plus 8 over sine theta. So when you substitute this theta in for cosine, and this theta in for sine, you're going to find out that you get approximately 18.2195 feet. And that is that video.